The Open Systems Interconnection OSI model, a protocol data unit or PDU, refers to a form of data transmission that includes both the data to be transmitted and the control information for the delivery of the data. The control information provides data handling instructions to the network layers that facilitate the delivery of the data. Data encapsulation in the OSI model refers to the process of adding headers, and sometimes trailers, to data as it moves down the layers of the OSI stack. Each layer of the OSI model has its own form of encapsulation by adding its own specific header to the data from the upper layer. The PDU is given a different name at each layer to represent its role. Take a look at each layer. The application layer is where the user interacts with the application they are using. For example, a user collects information from a website, www.google.com. In this layer, PDU contains original data made from a network application. Encapsulation at this layer often involves creating a data stream appropriate for the application. Select the next option. This layer translates the data format from sender to receiver into a common format. Encapsulation might include encryption and data compression. The data then will be passed on to the presentation layer and then to the session layer. Select the next option. Establishes, manages, and terminates the connections between the local and remote applications. It adds information to the data about the session, which helps in synchronizing and managing data exchange. Select the next option. The data will be broken into smaller pieces when entering the transport layer. During this process, the header is added, and this is extra information added at the head end of a PDU. This process of adding information to the data is the actual process of encapsulation. At this point, the PDU, the transport layer, is called a segment. Each segment is arranged in a sequence so that the data stream can be put back together when received exactly as it was sent. Each segment will go then to the network layer for network addressing and routing through the network. This layer is responsible for data routing, packet switching, and control of the data flow. It adds the source and destination IP addresses to the data packet, creating an IP packet. TCP segments now contain other information like the source port, which the computer sends the PDU, and the destination port for communicating with the receiving end. When the data reaches the network layer, it will now add an IP header that contains IP addresses from the sending and receiving computer. Select the next option. At the data link layer, the PDU now includes the network layer header, transport layer header, and upper layer information. This is called a frame. The data link layer will now take the packets from the network layer and place them on the network medium, cable, or wireless. The data link layer will encapsulate each packet in a frame that has a hardware address of the source and destination and other information which will specify to which protocol in the network layer should pass when it arrives at its destination. A tailored is also added at the end of the PDU. This sequence is used for checking errors. The frame is sent to a network node if the destination computer is on a different network segment before being continuing to its destination. The frame must be put into a digital signal. A frame is a logical group of ones and zeros. The physical layer will encapsulate these numbers into a digital signal, which is read by devices on the same network. The signals then will be transmitted to network media. When the data is sent through the physical medium, the receiving computer will also receive it on a physical medium and starts the reverse process of decapsulation. Click Next to continue. When the data reaches its destination, decapsulation occurs, which is essentially the reverse of encapsulation. Each layer removes its respective header and trailer, if applicable, interpreting the content until the data is finally handed to the appropriate application on the receiving end. This process is fundamental to network communication, enabling complex data transfers in a manner that supports error checking, data synchronization, and various network functionalities. Click the transport, network, data link, and physical layers to see what happens to the data at that layer. The transport layer will reconstruct the data stream and send acknowledgments to the sending computer that it successfully received each piece. The transport layer will be removed, and the remaining data is sent to the application layers and formatted for the needs of the user or application. Select the next option. The data link layer will perform an errors control action on the frame. The data link layer will remove any data link information or header attached when it was sent and passes the PDU to the network layer. The PDU is now a packet. Select the next option. The receiving computer will read the signal information, which is written with ones and zeros. Select the next option. At the network layer, the receiving computer checks the logical address of the packet. If the addresses match, then the network layer header will be removed from the packet and the remaining is passed to the transport layer. The PDU is now a segment. Click Next to continue.